When you're using a device such as a GPS, the radio, even using the weather network or watching television, those are all reliant on a machine called the satellite. What the satellite's doing is it's transmitting information from the satellite down to, for example, an antenna on the Earth. And when you think of a satellite, you're probably thinking of the machine that orbits the Earth. That's exactly what the definition of a satellite is. Yeah, the definition is an artificial body placed into orbit. Now, if you look at my first picture here, you're going to see why the definition, the keyword here, orbit, is very important in the definition. If we launch satellites straight up into the air, essentially it will just land back onto the ground, making a satellite basically completely useless. So that's why the second definition of a satellite, which is a moon, planet, or machine that orbits the Earth, or a planet or a star. And that is shown in the second picture. So, how can we make an object reach orbit? Well, before we can achieve it, we have to first find a way to send it into the sky. And usually it's, for example, a low satellite would reach, for example, the low Earth orbit is around 100 to 200 miles into the atmosphere, into the sky, in space, actually. So it requires an enormous amount of energy just to send something in the sky. So what we can use for that is engines or rockets, and it's going to create thrust, and the thrust is going to launch the rocket into the sky. It's going to be able to counteract the force of gravity and launch into the air. Now, when we're trying to reach orbit here, we're going to be, another word here is orbital velocity. And that means an object, in order to do that, is going to have to be going 7 miles a second just to reach orbit. So we can already tell here that's an enormous amount of energy. We do that in satellites, and we also do that with, for example, spacecraft. With spacecraft, I have another picture here, and the picture of the rocket ship. It's going to be the second picture. It will show you how a spaceship is launched in stages. If you look at the picture, stage 1 is going to fire its rockets, and once the fuel is all depleted, it will detach from the rocket ship. And then stage 2 will fire, and once that is depleted, it will detach from the rocket ship as well. And those are usually just destroyed from the fire in the air friction, or if it's low enough, it'll parachute back to the ground. Now, how do we achieve orbit? So to achieve orbit, obviously we need an enormous amount of energy, but that enormous amount of energy requires enough energy to make a perfect balance of motion horizontally and vertically. So in my third picture here, I have a diagram showing how this is going to work. Basically, if you look at the picture and you think of the black little dot as a bullet, the object is speeding by with a lot of momentum. As well, it falls to the ground because of gravity, right? But theoretically, if you had enough gunpowder to shoot it as fast as we possibly could, the object will continue to try to move forward while being pulled down by gravity. The balancing out of these forces basically moves it into circular motion, and that is what we call orbit. That is why if you were looking at, for example, a spaceship launching into space, or even a rocket, right? It doesn't just go straight up. Even for launching a satellite, they will go it'll go up, but not vertically, like not just straight up. It's gonna go at an angle as fast as possible, because to reach orbit, it has to have a lot of horizontal speed. So finally, how do we stay in orbit? So drag pulls down everything to Earth. There's drag just from the air. If you move your arm, that air resistance creates drag. So, for example, the ISS that's in the sky, that is a satellite. It's orbiting the Earth. The ISS is to counteract the forces bringing it down to the Earth. There are thrusters. The ISS is losing, every day it loses about 9 meters of altitude a day. And that's counteracted by thrusters, just giving it the force to stay in orbit.